Okay, I'm sorry. There's no way I can keep up that voice because it's killing my throat. All right, but anyway, let's do example 1A here. All right, we're supposed to write the equation for this ellipse. So I'm going to go really fast through these, try to get you going into the applications as fast as we can. So to write the equation for this ellipse, first thing I'm going to do is locate the center, which is just at -2, 2. And then I'm going to identify the A value and the B value. Well, my A value is the semi-major axis length, half of the major axis. So A is 2, and that's just always going to be the way it's stretched. This one is stretched horizontally, so A is going to be horizontal. And then B will be the opposite of that, vertical. So my B is 1. The semi-minor axis length is 1. And I got everything I need right there to make the entire equation. So remember that you change the sign for the center when you come in and out of the equation. So it's going to be x plus 2 squared over my A value. Because it is stretched horizontally, my A value is going to go underneath of x. And it is A squared that goes here, not A. Okay, so it's x minus the x value of the center squared over the A value squared. That's what I got right there. And then it's always x is positive and y is positive, so it's always going to be a plus with ellipses. And then I'm going to have y minus 2, because I changed the sign of this 2 when I put it in the equation, squared. And that is over the b value squared, which 1 squared is just 1. And then this is always equal to 1 for an ellipse. So there is that ellipse equation right there. Let's go ahead and move to the next one. This one has the center at 0, 0. So my equation is going to be x minus 0 squared plus y minus 0 squared, and it's always equal to 1. That's really how I like to set them up right away. Just put in the center right away. Then I come back and do A and B. All right, this one is also stretched horizontally. A is just going to be 3, and B is just going to be 2. And since it is stretched horizontally, the A value is going to go underneath of x. Remember, it's A squared that goes in the equation, so it'd be 9. And it's B squared that goes underneath of y, so it would be 4. There's that equation. All right, let's move on here. Let's go to just the same type of example, just the opposite direction. This time I'm giving you an equation, and you have to find the graph. All right, so we're going to find the vertices, the co-vertices, and the foci all in this graph. All right, let's start with our center. Start the same way I did before with the center. The center, pulling it out of this equation, is nothing more than 0, -2, just changing the sign. There's no x minus 0 here. There's no value, so it's 0. And then a -2 when you pull it out, you just change the sign. So 0, -2 is my center for this ellipse. So I'm going to start there and graph that. There's my center. Everything is going to count off of that center. So make sure you never miss this point by negative. You'll miss everything. All right. My A value. Now this time, this is the first time we've ran into this. The A value, the bigger value, because remember, the bigger value is always A. The bigger value is underneath of Y. So that means this one is going to be stretched vertically, not horizontally. Okay, the bigger value being underneath is going to stretch it vertically. It's underneath of y, I'm sorry, it's going to stretch it vertically. So my A value is always the bigger value. It's going to be 3. Remember, that's A squared, so A is 3. And then B is going to be 1. So I'm just going to go ahead and graph these to find, or count on the graph to find my vertices and co-vertices. So I'm going to count 3 units up. There is my vertex, 3 units down. There is my vertex. My vertices are vertical on the graph because it's stretched vertically. All right, my co-vertices are going to be 1 unit to the left, 1 unit to the right. So these are my co-vertices to the left and to the right. So I can draw my ellipse right now. This is a big time stretched out ellipse. All right, there's my ellipse. That's about the best I've ever drawn an ellipse in my life. All right, so there is my ellipse. And then the tricky part is the foci. The foci come from what I call the messed up Pythagorean theorem, because it's not a squared plus b squared this time equals c squared. It's a squared minus b squared equals c. Because a is always going to be bigger than b and c, because the foci, I'll just tell you, they're going to be about right there on this one. They're going to be way towards the vertices. But it's still smaller than a, my c value. All right, so just plugging in what we know a squared is 9. We know b squared is 1. So I got c squared equals 9 minus 1. And that means c is the square root of 8, which is about 2.8-ish. And I'm just going to use an approximation. So I'm going to go from the center, and I'm going to go 2.8 units up, 2.8 units down. That's where my foci are. They've got to be up and down on this one because I'm stretched vertically. The foci will always be on the major axis. They'll always be on the major axis. All right, let's go ahead and do the next one. The next one here, this one has a little trick to it because it's not in the form we want. It's not equal to 1. So the first thing we got to do is get this equal to 1. And to do that, I'm going to go ahead and divide by 144 because that'll make it equal 1, like I want it to. All right? So let's go ahead and do that to both sides. If we divide that side by 144, we got to divide this side. I'm going to distribute my division to both terms. And then to get it in the form I want, we don't want anything in front of the x squared and the y squared terms. Okay? So I need to get this 9 out of here. And the way you do that is you just simply simplify the 9 and the 144. Okay, so take 9 over 144 and just simplify the fraction. Well, 9 goes into 144 evenly. It goes in 16 times. So I can simplify this down to divide the top by 9, divide the bottom by 9. And I can simplify this to x plus 1 squared over 16. And then 12 over 144 simplifies to 1/12. So I can simplify it to y minus 1 squared over 12. Now I have it in the form I want. I'm going to fly through the rest of this really, really quickly. All right, so just drawing my xy axis here. My center is at -1, 1. Change the signs as you pull them out. -1, 1 is my center. My a value is going to be 4. The bigger value is underneath of x this time. It's going to be stretched horizontally. Okay, so I'm going to go ahead and count 4 units left, 4 units right. I just found my vertices. And then my b value is going to be a little ugly in this case because the square root of 12 isn't nice. It's irrational. But I'm just going to estimate it real quick. The square root of 12 is, let's see, right around 3.4-ish, 3.5-ish. I don't have a calculator on me. I'm just 3.4-ish. So I'm going to go 3.4 units up, and I'm going to go 3.4 units down. There are my co-vertices. All right, so this thing is not too far from being a circle. And wow, this one showed my true artistic ability. That's terrible. All right, so, wow, that's bad. All right, so there are my vertices and co-vertices. And then to find the focus, I'm going to use the messed up Pythagorean theorem. C squared equals a squared minus b squared. And plug in what I know. I know that a is 16. I know that b squared is 12. So I got my a squared is 16, b squared is 12. And so c is going to be equal to 2 because 16 minus 12 is 4. Square root of that is 2. So I'm going to count 2 units. Now this time I'm counting left and right because remember, it's the focus. Each focus always has to be on the major axis. They're always going to be in the longer direction of the ellipse. So there are my foci. All right, we'll go ahead and continue on the next video and show you some applications.